Hello friends, in this video I will talk about NetworkX, a Python library most widely used for network or graph programming packages in Python. And we can see that creation and manipulation and study of structure, dynamic function of complex. It's all about working on complex networks. And here you can see the alphabets. They are called as nodes and they are connected with some arrows. Those are labeled as edges in this NetworkX library. And actually we will mainly focus on these networks, how to manipulate those distance between these nodes. And we can uh, we can see through next slide. Yeah, key features of NetworkX. Here, first of all, if we go to graph representation, in graph representation there are four types: graph, digraph, multi-digraph. Uh, Here we can see in graph undirected graphs with self loops. If we connect the node with self node, then that is called as self loop. And undirected graphs means there is no directed edges. Here in digraphs we can see that there are self loops and there are directed. Digraph means there will be direction of that edge. In multigraph, undirected graphs, here you can see no direction. And multi-digraph, here you can see directed graphs with self loops and parallel edges. Yeah, I think you can see this. And graph creation, if we go to graph creation, there are some syntaxes: nx graph, nx digraph, nx multigraph, and we can add nodes, add edges. Yeah, we will see some code examples. And manipulation modification also we can see through the code examples. In network analysis, by using NetworkX, you can easily find different types of parameters like degree centrality, clustering coefficient, connected components, community detection, etc. And if you go to graph visualization, you can visualize graphs using matplotlib through functions like nx draw network, allows customization of node size, color, edge width, labels, and more. In graph algorithms, you can find of different types of algorithms like shortest path, minimum spanning tree, page rank, max flow or minimum cut, and the etc. In integration with other libraries, NetworkX works well with these libraries, allowing easy manipulation of graph data in matrix form for linear algebraic operations. NetworkX graphs into pandas data frames for more efficient data handling and vice versa. Let us see some codes related to graphs. If we go to simple graph, we first of all adjust the nodes and edges. Here there is no directional, so it is a simple graph. And if we go to direct graph, we are adjusting nodes and we are giving the direction, add edges from, and here we are getting the directions. And if we go to weighted, we are giving the edges with weight matlab, it's around length of that edges. And biparty, it means where nodes are divided into two sets. uh, by those two sets we are adjusting those nodes and adding those nodes with edges. In random graph, there is a syntax called Edo's any model. We can add we can generate it and add those edges with a probability. And the final conclusion of this NetworkX is a powerful and versatile library for creation, manipulation, and study of structure, uh, dynamic and functions of complex networks. Thank you.